Would you just half all of that vector?
So yeah, if it helps, sub in 2 first and then multiply everything by a half, so they might actually cancel each other out.
Yeah.
Uh,
So but where's 12i and 10j come from?
so I just subbed in t equals 2 into both of those.
Oh yeah, 6ti and then. So is it just 6i minus 5j?
Yeah. So that's f, and then find the magnitude of that.
Is it 6i squared
Mm-hmm.
plus 5 plus minus 5j squared square root?
And yeah, you can do it without I and j now.
Oh yeah.
So just square root of 6 squared plus 5 squared.
It's root 61.
That's it. And then the bearing, how do you do that?
I'm not sure with the bearing.
So if you have a sketch, f was 6i minus 5j, so it's going to be something like that.
Yeah.
And so what you can do is find this angle here. Any idea how you do that?
Are we using trigonometry?
Yep.
So no, I'm not sure.
So to get that angle, this is the adjacent.
Yeah.
This is the opposite.
Yeah.
And so how can you find the angle?
So is it opposite of opposite over adjacent?
Yeah.
Minus 5 over 6.
And did you get 39.8 for that?
Yeah.
Or minus 39.8? Yeah. So that's coming, I just did it at the plus version, so that angle is 39.8 and it's given minus because it's going under. So that's 39.8 degrees. They want the bearing. what's a bearing?
Is oh, no idea. I don't know what that is.
So bearing, point north, turn clockwise, and stop when you hit the line. And so in this case, the bearing is that angle and
90.
the thing above it. Yeah. And so what is the bearing for this one?
The bearing would be 129.8 degrees.
That's it. So it's 90 plus 39.8, and so it's 9.8 degrees. So let's see. They asked for F, the force, and they gave us the mass and the acceleration. So we're using F equals ma, and you use that a lot, in different things. A had t in it, so we just had to sub in that t to just turn it into a number.
Yeah.
Just work that out to get it as a vector, and then do Pythagoras to get the magnitude. And then the bearing, to find the angle, it's always inverse tan of j over I. So theta is always inverse tan of the j over the I.
Right.
Because it's always the j is always the opposite, and that's always the hypotenuse, always the adjacent.
Yeah.
They just added a little extra thing that they wanted bearings. You had to add 90 to it. It helps to just do a little sketch. Like if this had been 39.8 degrees up here, then it would be 90 minus it or whatever. Any questions there?
No, obviously the bearing's a bit new, but it's alright.
Okay. So bearing is like they're at GCSE as well, so they're just not. See, the problem is they're not really emphasized that much at GCSE, and then all of a sudden, everything it's just assumed that you know it. But anyway,
yeah.
Just do a sketch. Point north, turn clockwise, and stop at the line. Okay, how about this one?
Struggled with this one in the exam because I was trying to work out whether what to use. Was it Suva?
So there's definitely some Suva stuff you can do. Let's take a look. So the mass is 1.5. So it starts from rest. So what's that tell you?
The initial velocity is 0.
So u is 0. Time is 2.5. And a is 2. So they're giving us lots of information there. What else? What can we find from this? UTA. So we could find distance, which is s, and we could find final velocity, which is v. Okay. Subsequently, when the only horizontal force acting on the boat is a constant resistance to motion, the boat travels 10 before coming to rest. So I think there's like two different journeys here. One is this first part where it starts from 0 and it accelerates 2 per second for every 2.5 seconds, or for 2.5 seconds. So that's the first half of the journey, and then the second half of the journey, it stops accelerating. I think the boat travels. Calculate the magnitude. Yeah. So let's say for this first half, what you can do to bridge the two is you can find v, and that way the v for this journey, the first half, is the same as the u for the second half.
Right. Yeah.
Like the final velocity for this half is the initial velocity for the second half. Yeah, so how would you find
when that ends, the other one starts?
Yeah. So how would you find V for this
one? Well, would you get the whichever Suvat equation we need, which is the one. Would you just sub those values into one of the Suvat equations?
And so which one? Do you know which one involves V, U, T, and
A? V squared plus.
No.
No, I'm not sure.
U plus AT.
U plus AT.
So use that to work out V.
So V equals 5.
Yeah, that's it. So V equals 5. And so that's the first half. And then for the second half, U would be 5. So they tell us the mass. So it might be, and it involves the force, resistance to motion. Yeah, horizontal force. So there's probably an F equals ma as well. Let's do F equals ma as well. Find out what that is.
So 1.5 times 2. So that's 3. 3 newtons.
5 times 2. That's 3. Okay. Let's see. So subsequently, when the only horizontal force acting on the boat is a constant resistance to motion, the boat travels 10 meters before coming to rest. Okay. So, any idea what you can do for the second half?
For the second half, is it Suvat again?
Yep.
So get all of our values again, except for this time we've got V as U. And now we're looking for what are we looking for?
So
resistance to motion, but what would that be?
So I would start by listing the stuff that you know.
Right. Okay. So we've got the initial velocity, obviously, which is 5. The mass, which is 1.5. Still.
Yeah.
The acceleration. Oh no, because it's.
So it doesn't tell us acceleration.
No, not got acceleration. We've got. We've got 2.5 seconds still. Start from last 2.5. That's for the first half again, then.
I don't think you can do the 2.5 seconds.
No, because that's only when it's pushed and it's asking afterwards.
Yeah, so for the second half, I don't think it's 2.5 seconds.
10 minutes before coming to rest. We've got the displacement of them.
Yeah.
10 meters.
And there is something else. If it comes to rest, what does that tell you?
As No acceleration. The final velocity is 0.
That's it.
Yeah.
Final velocity is 0. So if you have to find the force that's resisting motion, we're going to be using F equals ma again. The problem is we don't know the a. We know it's going to be a negative number because it's slowing down.
Yeah.
And so how can we find a?
It's the Suva equations again, but I'm not sure which one. The one that, well, obviously the one that starts with.
So I think v squared equals u squared plus 2as. Yep. And they give you the SUVAT, so you just kind of look up which for.
Yeah, they are on the formula sheet, I think.
Okay, so this
2as. So we just sum in everything we've got.
Yep.
So we've got 0 squared, which is just 0, equals 5 squared is 25 plus 2 times a times 10.
Yeah. And just go from there.
So we've got 25 plus 2a. Oh no, times 10. Plus, is it 20a? 20a?
Yeah.
Equals 0. So
So tell me when you get an answer.
yeah, sorry. Is it equals minus 25? 25. Minus 1.25.
Shift solve. So you can see how I just put it into my calculator.
Yeah.
The working out. Shift solve equals minus 1.25. And so how do you use that to get the resistance to motion?
1.5 times 1.25.
Yep.
Equals the force. Which is 1.5 times 1.25 equals 1.875 newtons.
1.875 newtons. Yes, that's it. So let's see. So we actually didn't need to find this F equals ma for the first half. I just wasn't sure how it would work. Basically, it's just F equals ma to get that. Problem was we didn't know a, and so we had to get a. But in order to get a, we needed v, and so v for the second half was u from the first half. So just suva for the first half to get v. That becomes your u for the second half. Suva again to get a, and then sub that a in to get into F equals ma. And you can see how you can kind of tell it's going to be a Suvat one, and just keep finding stuff that you can until it kind of starts to make sense.
Yeah.
Any questions there?
No.
Okay, yeah, and it makes sense for this second bit. A is negative because it's slowing down. And yeah, okay. Let's slow down. Okay, this one. Detail reasoning. Sorry a sec. Okay, let's take a look at this one. Sorry about that.
So do sub 7.
So yeah.
So we've got minus 0.7.
And so a boy plays on a path north-south through an origin O. So it's just straight up and down, I think. So I think the path is like that.
Yeah.
North is there, south is there.
Oh,
A boy plays on a path that runs north-south through an origin. It's displacement north of O. So I think his position is what did you say it was? Minus 0.7 or something?
his position, sorry.
Is it? Did you sub in 7? Was it?
Oh yeah, sub 7 got minus 6.3.
Minus 6.3.
Yeah.
So x equals minus 6.3. So that's his current position. So he's like down here.
Yeah.
But in which direction is he traveling? Is he traveling back up or is he continuing down? Any idea how you do that?
No, I'm not sure.
There's a few different ways you can do it. So basically,
What topic is this, sir?
this is maybe like modeling.
Right.
There's a few different ways you can do it. That's the thing. You can do it using differentiation. You can do it using graphs. So what's kind of confusing about this is they call it x equals, but that's actually, it's going up and down. It might have been easier if they just called it y equals, because that's usually what you'd say. How could you sketch the graph of this y equals minus 0.7 x squared plus 4x? Or I could use t, I suppose. We'll stick with t.
Could you do it on the calculator?
Do you have a graphical calculator?
Yes.
Great.
Yes, I know, about time. I'm not too sure how you set up a graph on it though.
So my thing just ran. My 3-month trial just ran out on this graphical thing, and I have to. I don't know how to actually buy it. I tried buying it, and it's not easy because it's all Chinese. We could just do it the old-fashioned way. So factorize out the t or solve it.
I think I figured it out, to be honest. Why? T. No, maybe not. Yeah, go on, we'll do it there.
So I think factorize out t. 7t plus 4. There's a few different ways to do it. I think so either you just draw the graph and say so it's a negative quadratic, and so it's gonna look something like that.
Yeah.
And you would just say, like, if 7 is like less than the halfway point, then it's increasing. If it's past the halfway point, then it's decreasing. That's one way to do it. I think another way you could just differentiate it.
All right. Okay.
So what
So
would that be?
minus 1.40 plus 4.
Minus 1.4t plus 4, and you would sub 7 into that.
Right. Okay. So it's just recognising that we need to use dy dx or dx dt in this case.
Yeah.
Okay, so I got that to be minus 5.8.
And so what does that tell you about the direction he's moving?
That is going south.
Yeah. It's like decreasing or south. Yep. And part 2.
So I just have a question. Sorry, what does finding the derivatives actually do?
So it finds the gradient.
Yeah.
And so you can see on the left half, the gradient is positive.
Yeah.
On the top, it's 0. And then here, it's negative.
Yeah.
And so he was increasing. Then it was like stationary. And then he's gone back down again. And so he's currently going towards south in this case.
Yeah.
So I think it would have been easy. It would have been made more sense if they just called it y equals, because it's about up and down. So it just tells you that the it's decreasing. Negative, yeah, dy dx is negative, decreasing.
Yeah.
And then how about question 2?
Find the furthest distance from reached by the plan. Yeah. So we could go either way then. We could either go positive or negative for this, but it'd be easier to go positive, wouldn't it?
That's a good point. Yeah, it could be the most negative thing.
Well, I think we should go for positive.
Okay.
So find the furthest part. Do we sub t equals 10 in?
So I'm subbing in 10 just to see what I get.
Yeah. Because that would be if it's 40 t to 10.
So that's minus 30. So that's my graph has to kind of continue on down to here. So that's minus 30. How high up is it at the maximum though? It could be plus 40.
Isn't that going to be 30 up as well?
Might not be.
So do we sub in 0?
Yeah, into where?
Into the 1.4 minus 1.4 times 0.
No.
Is it the original?
Sorry?
Or is it into the original?
No. It's not t that is 0. It's dx dt that is 0. So like the gradient is 0.
Right.
Or the rate of increase.
0 equals -1. And then are we solving for t?
Yeah.
I've got 2.857 to 3 or to 4.
Yeah.
The places.
So that's 2.8471. And so is that the distance?
No, it's not. That is the is that then what we need to sub into back into the equation?
Yeah, well done. Back into the original.
Yeah. So uh, 2.57 plus 4. Is it 5.714?
Yeah. So the height is up at like 5.7, 5.71. And so furthest distance from O
is -30.
Yeah. And so it's distance, so we'll just say 30.
Yeah.
So that's 30 meters. And this is why for this question they said you have to show detailed reasoning. So both answers you could have just gotten for a shot, but you have to actually check that the other one isn't the case. So basically they give you an equation that tells you what turns out to be like the y coordinate of the boy at any time. So like after 1 second you'd sub in 1 and that would tell you where he is and so on.
Yeah.
So it can help to kind of sketch a graph to make sense of it. Basically what direction he's going after 7 seconds. So if you sub in 7, that tells you where he is. But to find his direction, you'd have to say like, is he increasing, is he decreasing? And so you would differentiate it to see, is it increasing or decreasing, is it positive or negative? And sub 7 into that. And to make sense of that, you can just sketch a little graph and you can see it's increasing on the left, decreasing on the right. Find the furthest distance from O. It looked like it was going to be the 30, but you just have to check the other one as well.
Yeah.
Any questions there?
No, that's all right.
Okay. Let's see. Let's type out. That was detailed reasoning. Where's the... So that's that one. Did that one. This one. Okay, how do we do this one at the top?
3 squared minus 4ac.
Yeah. Are you okay for that one, or?
Okay. Well, I haven't been through the test yet in lesson, so When I was answering it, I think I got as far as subbing everything in.
Okay.
But I don't think I managed to fully complete. I think I got a couple of marks on.
Okay, go on. What is it?
So B squared would be K minus 5
Yeah.
squared. And then minus 4 times 1 times 3.
Yeah.
And then I expanded the
Hold on. That's going to be minus 3.
minus 3, so yeah.
Yeah.
And then I expanded the K minus 5 squared.
Yeah.
To get, was it K squared minus 10K plus 25.
25. And then that times that is plus 12.
Plus 27 altogether.
Is it not plus 37?
37, yeah.
Okay. And any idea what you do next?
Is it factorizing?
I think just, let's see.
Well, making it equal to 0, or is it greater than 0?
I think greater than or equal to 0, because it says it has real roots, but it could have the same root twice. So let's just say it's equal to 0, and we'll go from there. And then you just solve it using your formula, using your calculator. So A is 1, B is minus 10, C is 37. Hang on a second, that part has no real roots. Show that for all values of K, the equation has real roots. We've done this absolutely the right way. If it has real roots, then it's greater than or equal to b squared minus 4ac. Let's just say it's greater than 0. So that must be greater than 0. So there's another way to show this. Is greater than 0. But it is... what you might have to do then is complete the square.
Right.
That's the other way you show that it's... So how would you put this into completed square form?
Is that K minus 5K?
So K minus 5.
That's just K minus 5 squared, and then plus plus 37 plus 25.
Minus 25.
Minus 25.
Because that expands to give you an extra plus 25.
Yeah.
So simplify that.
So it's K minus 5 squared, and then you're left with a plus 12.
12 is greater than 0. What do you know about K minus 5 squared? Anything squared. What's the lowest value you can get for
it? 1 has to be above 0.
Yeah, so basically that's always greater than or equal to 0.
Yeah.
Therefore, K minus 5 squared plus 12 is greater than 0.
Which means it's always going to have real roots.
Yeah, therefore b squared minus 4ac is greater than 0, which is what that is. Therefore, real roots for all values of K.
Yeah. I know it's not relevant as well, but would that be minimum points as well? If it's above 0?
Minimum, yes, yeah. The sort of minimum for this is 12.
Yeah.
And that's when K is 5. Yeah, so like if you were to do it as a graph, the minimum would be at 5, 12, yeah. Yeah, so this one we couldn't do it using the formula, so we just do completed square form. And the square thing is always greater than or equal to 0, and so obviously plus 12 definitely greater than
0.
Yeah. Any questions there?
No, sorry. I just obviously need help with I didn't know where to go when it came to completing the square. So. I mean, in the exam. Sorry, in the exam.
Yeah. So the trick there is, if you have to find like the to show that it's got like the minimum value, you use completed square form. Okay, how do we do this one?
This is the topic I haven't done. I wouldn't be sure on this one. I know that it involves subbing in the equivalent of what sin and tan would be equal to, or cos would be equal to, isn't it?
So what I'm noticing is they've swapped from having sin x and tan x to just cos x. So any idea how you can go about that?
No.
So how could you write tan x in terms of cos? Something to do with cos.
Is it cos over sin?
Other way around. Sin over cos. So 2 sin x tan x becomes 2 sin x over cos x. Any idea what we do next?
Take the cos x plus 5 to the other side.
Well, that's not really a pressing concern just yet. So I'd simplify this.
Right, I'm not sure I do 2 sin x cos x.
So one is what is sin x times sin x?
Sin x squared.
Yeah, and we write that as sine squared x, which means the same thing.
Yeah.
So it's that whole thing over cos x. So like you're just multiplying fractions basically. 2 sin x over 1 times sin x over cos x. So next I would get rid of that fraction. So it's not a fraction. There's no fraction here. And fractions are difficult. How do you make it so the left side isn't a fraction?
Times 2 by cos x.
Yep. And so what do you get?
Cos squared x plus 5 cos x.
And what's now on the left side?
2 sin squared x.
Yeah, so we're getting close, but we have sine squared x. We want to turn everything into cos. What can we do?
Is there a way that sin x can be written in the form of cos or not?
Yeah. Do you know it?
No, I don't know.
Sine squared x plus cos squared x is equal to 1, basically. And so sine squared x is equal to?
Sin squared x plus 1 minus cos squared x.
Yeah. And so use that to remove sine squared x from this thing. What do you get?
1 minus cos squared x. 2 times 1 minus cos squared x.
Yeah. And then you go from there.
So I expand that bracket, would I?
Mm-hmm.
So 2 minus 2 cos squared x.
Yeah. And then what's next?
So that is equal to.
You're trying to make it look like their one.
Yeah. So take everything to the other side.
Yep.
And then that's it.
And that's it. Yeah, I think you'd be fine to
3,
just.
Yeah. 3 cos squared x plus 5 cos x minus 2.
Yeah.
Equal to 0.
That's 0 equals 0. So basically, you have to turn everything into cos, and you've got sine x and tan x. Well, first of all, tan x is sine x over cos x. So I would do that first. The reason why is because you can swap between sine squared x and cos squared x, but you can't swap between sine x and cos x. That involve like square roots and stuff. So I thought maybe we can avoid that.
Yeah.
So change tan x into sine x over cos x first. Just simplify it and remove any fractions. Just kind of keep it simple. And then swap sine squared x for 1 minus cos squared x and simplify that. Any questions there?
No, that's fine.
Hence, how do you do this next one?
And solve the equation. So, do we need to use what we've already got?
Yeah.
So can we change the sign in the tab?
Well, hence meaning it matches up with the previous one. So these two match up with each other. What's the only difference between them?
Theta and 2.
So basically, x equals 2 theta.
Oh, right, yeah.
So what I would do is, so we know that these two are the same as each other. So I would solve this one. How would you solve this?
Just the middle one.
Yeah.
I using the middle one to solve the third one.
And how do you solve the middle one?
Do you sub 2 theta in, or do you factorize it?
Even simpler than that, I would just go straight for calculator because it's like quadratic.
Right,
yeah. So A is 3, B is 5, C is minus 2. So we get cos x is a third. Or cos x is minus 2.
Yeah.
How would you solve the one on the right? Cos x equals minus 2.
Uh, 2 over cos x. 2 over cos.
What's the opposite of cos?
Inverse cos.
Yep.
So, cos inverse minus 2.
Yeah. What do you get?
I'll put it in now.
Something's gonna happen.
Error.
Yes, that's because the cos graph only goes down to -1. It's outside the range.
Yep.
And so we only need to get the answer for this other one.
Yeah.
Cos x is a third. So that would be for the first one. But we can see down here for the second one, we said x is 2 theta.
Right.
And so cos 2 theta is a third. And that's the one we have to solve. The other one has no solutions. So theta is a third. So how do you solve that? In fact,
so
let's just do cos x equals a third. We can just do it at the end.
Yeah. Inverse cos third is equal to x.
Yeah. And what is it?
1.23 is it?
That's in radians, is it?
Yeah, it will be.
They want it in degrees.
I'll just see if I can switch them around.
Nah, let's do it. Shift cos 1/3. So it's 70.5. How do you get additional answers? Or are there additional? Hang on, it says it's between, I think it's between 0 and 180. Okay. 0 and 180, that's theta. So that's it really. But we said for the second one, so that was for part 1, but for actually part 2, they said x is 2 theta. Like you spot the difference.
Yeah.
And so how do you get what theta is?
Divide 70.5 by 2.
Yeah.
So 35.25 is equal to theta.
35.25. And I think actually they said theta is between 0 and 180. And so I think 2 theta we'd have to look at between 0 and 360. So we would have to get the second answer. How would you get the second answer for x? How do you get second answer for cos?
Is it? Do you do the normal cos, not the inverse?
So for second answer, you do 360 minus for cos. So 360 minus first.
Right.
It's because the cos graph is symmetrical about 180.
Right. Yeah. I do remember now. Minus 7.5. Yes. 360. 289.5.
289.5, and so that's x, which is 2 theta. And so what is theta?
289.5 divided by 2.
Yeah.
Which is 144.75.
144.75 degrees. There you go. Let's see. So this one, yeah, it's definitely a quadratic. The only trick is it's not x equals, it's cos x equals. So with your two answers, one of them is outside the range, so we don't worry about that. And so the other one, cos x is a third. Basically, you just solve it, and then half your two answers, because if you spot the difference, 2 sine x tan x, 2 sine 2 theta tan 2 theta, the x is equal to 2 theta.
Yeah.
Any questions there?
No, sorry.
All right. Well done, Conall. How was that for you?
Definitely cleared some things up on the test. Yeah, thank you.
So is there anything in particular you want to do next time?
I think is there one question left or two questions is it on pullers?
I wasn't sure. There was definitely something left. Hang on.
I think
Yeah,
it's a pullers question.
if you want, we can do the remaining questions.
Yeah, I think there's just one.
Okay.
And then I'll get back to you at some point this week with what else we can do.
Okay. And I can check as well. Any questions for me in general?
Yeah. My dad was just wondering where we're up to with the lessons and payment, and how many more lessons we've got left, or is he into needing to pay you now?
I'd have to check. I never checked, to be honest. So I'll check and email him.
Yeah, perfect. All right, I'll let him know.
Okay.
He says he's happy to pay for more lessons. It's not a case of that. It's just he needs to know how many he's paid for, and that's
okay.
Perfect.
Anything else?
No, that's it. Thanks.
All right. Well.